Okay, so I'll briefly refresh whatever we have talked about in the last class, at least with respect to equality, and then continue talking about equality and cloning in this class. Okay, so let's get started with equality. Um, so this is one of the default method that comes with object, right? So there's a class called object, which is the parent class for every other class that you create, and that happens by default. So you don't have to explicitly extend object class, but it gets whichever class you create, it automatically extends object, and that's why it has access to all the public methods of object. And equals happens to be one of the public methods of the object class. So let's briefly look at what equals does, right? So we looked at this slide in the last class, and we'll just go over it again. So you have, let's say there's a class called point, and it has two instance variables, which refers to the two coordinates, x and y coordinates, right? So you have 5, 3. So it has a constructor that takes two parameters, x, y, and then you can pass in the values of x, y here. So you create one instance called P1, and you put in P5, 3 as the arguments of the constructor. So P1 refers to a memory location that holds these two values, x and y, which is 5 and 3. And now you create another instance, which you are calling it as P2, and you are again passing the same values, which is 5 and 3. So again, P2, there's a memory location created and then that memory location is referred to as by P2, and within that memory location, you have the values of x and y. You also create a P3 and simply assign P2 to P3. Right? So now now if you do an equality check, so equality checks the value within this particular variable matches with that of the variable on the right hand side. Right? So P1 and P2's memory locations are different. So this is false. P1's and P3's memory locations are different. So this is also false. And the third case, P2 and P3 are referring to the same memory location, right? Because it's a reference, and you assign the reference to P3. So P2 and P3 are referring to the same memory location. So that's why it's true. But yeah, in theory, you may actually want to, or the intention was to compare the values, right? So you may have actually wanted to compare, say that, okay, point, it it is the state of the instance P1 is 5, 3. So it's the coordinate 5, 3, and P2 also is pointing to the same coordinate, which is 5, 3. So from that point of view, P1 should be equal to P3, sorry, P2. Maybe that's what you had in mind, but since you used the default implementation, so which again here it compares the values, right? The values of P1 and P2, and not the um, the values within the memory location, which P1 and P2 refer. So this may not be the expected result that you are looking at. So there needs to be some changes. So especially in the case of these objects, right? It doesn't do a good job. So you would have to override the default implementation of equals and provide your own implementation. Right. So okay, let's. So the default implementation it's of equals is pretty simple. So it returns a boolean and it takes a generic type called object. So that's why you can pass in any type, right? And it is okay. And it simply uses the double equals operator. So it checks whether the value on the left hand side is same as the value on the right hand side. Right? If it is same, then yeah, it will return true. If not, it will return false. And if you are also using inheritance, you can, I mean, so that happens by default, like I said. So because equals is a method of object class, and if you create, let's say, point class, it automatically inherits the all the public methods, of which equals is one of them. Okay. So you would have to override this equals to test for the equality in terms of the instance variables. Okay, so let's say, okay, yes. Um, so the correct way to check for equality is to override the equals method. And now here it's up to you how you check the equality. So in this case, we are checking whether the x and y coordinates of the current instance is same as the x and y coordinates of the instance which is passed as the argument. Right? So here we are comparing the x of this instance with o dot x, and if y is also same as o dot y, then you return true. If one of them is different, then it's a false. It will be false. But okay, so although the intention is correct here, uh, there are some issues with this code. So the first, the issue is here is um, equals in the object class. So that takes in the argument as object. So here the argument should be object O and not, you cannot have point O. So again, when you're overriding a method that is in the parent class or super class, you cannot change the signature. Right? We already discussed that. So in this case, it is changing the signature because one of the arguments, the type of the argument is getting changed. So that is the issue here, and that's why it will give a compilation error. So if you want to override the existing method, then you would have to stick to the same signature. So that means this should be object and not point. So if you do something like this, where you change the signature, it becomes overloading and not overriding. But here you already declared that you're overriding it. So you would have to use the same signature.
Excuse me, sir.
Yes.
So if we remove override here, then it will work fine, right?
Yeah, it works fine. So if there is no override, yeah, it will treat it as an overloading, and yeah, it works. It works fine in the sense it doesn't complain, but it won't do whatever uh, you asked it to do. So, for example, you want to check the equality of two point instances which have the same x and y coordinates. So that will not happen.
Okay.
So yeah, so if there is a question, do unmute and ask, because I don't generally check the chat messages. So the question is there any relation between equals and hash code? So I don't think there is any relation. So because like I said earlier, the default implementation of equals is this one. So it simply uses the double equals symbol. So double
Excuse me,
equals
sir.
operator. Yes.
So once I was implementing a hash set, and I wanted that if I add element again, which is already in the set, then I don't want it to be added. So basically, I want a hash set of unique elements. So for this, I overrided the equals function so that the hash set basically checks if two objects I'm inputting are equal, then it won't add it, right? So in this, when I did not write the code for hash code. I did not write the method hash code. It basically the functionality was not implemented. That is, duplicate elements could be added. But when I overrided the hash code method, then all the elements were unique. So I searched about it on the net, and Stack Overflow said that usually you need to implement the hash code as well with equals, but I could not really understand the reason behind that.
Okay. So in your case, so okay, hash set already does this functionality, right? So in that sense, at least for hash set, you don't need to do that. But let's say if you are trying to replicate the functionality of hash set, yeah, then we can think about it. Right? So again, okay. So what you're doing is something slightly different. So okay, let's see. So when we say O1 double equals O2, or let's say O1 dot equals of O2, you are comparing two different or two objects, right? But if you are saying hash set, then um, you are trying to compare the values within that particular instance, right, of hash set,
My
or
hash
within,
set.
sorry, within the hash set, you are trying to compare the elements.
Yeah, so my hash set basically had objects of a user-defined class, which
Hmm.
I defined. So I
Ah, right.
wanted
Okay.
the sets to be. I mean, I wanted ki if a particular parameter is equal, then I don't input it again. So for example, the name, right?
Right.
Of the
Right.
I have a
Okay. Okay. Okay.
yeah.
Now
So
I got. Huh.
yeah,
Okay.
that's what my question was.
Okay. So something like so hash set of say employee, right? So okay, we didn't talk about this, but okay. So you wanted, let's say, hash set of some other user defined types. Okay.
Yeah, and in this case, suppose I wanted that if two employees' names are equal, then they shouldn't be added again in the hash set. So this couldn't be
Right.
implemented.
Right. Right.
For this, I need to override the equals so that hash set can compare two objects on the basis of my parameter, what I am defining for equals.
Hmm.
And for this, if I didn't implement hash code, then two employees with same name could be added. That means the functionality I wanted to implement was not being implemented. So for this, I
Right.
needed to, when I overrided the hash code, I didn't really know the reason, but I saw on Stack Overflow that you should. I did, and after that, unique elements were there.
So in your case, what was, how did you, I mean, what was the implementation of hash code? In a sense, how did you
So
generate the hash code?
I wrote the int hash code, and then the inside that I wrote return employee dot name, a dot hash
Oh,
code.
so the hash code is the name.
Yeah.
Okay. So yeah, so in this case, right, you are um, so hash obviously anything that's related to hash, like hash set or hash map, um, so they do need the hash code, isn't it? Like to place it, to place the element in the slots, one of the slots,
Yes. So
isn't
it
it?
does
So
it.
so in that sense, yeah, so it is required. But let's say if you do it for a regular, I don't know, so in our case it's a point where you are not placing it in any hash map or hash set. So in this case you don't need to override hash code also. This is sufficient. So when you say point p1 equals to, in the example that I so point p1 is equal to new point p 5 comma 3, and then you create point p2 with the same values. And now you can say is p1 equals p2. So it should return true. So in this case, since you're not um, doing anything related to hashing, right? So you don't need the hash code. But yeah, if you're doing something with related to hashing, and um, so okay, the reason there is because, like I said, it's hashing. So let's say you in your hash, I'm just giving some example. This is your hash, say hash set h, and if you take 1 2 3, uh, and let's say you added one more element which is same as the previous one, so it knows that 2 is equal to 2 because it's internally using that, right? And that's why, I mean, the implementation is already there, and it's there for the basic data types. But if you don't, if it's not a basic data type, then it wouldn't know how to compare the different elements of this hash, and that's why you need to, I mean, obviously override equals. But in order to place it to the respective slots, so when you place two here again, it's a collision or a conflict, right? It's a collision because this hash is coinciding with the existing hash. So in that sense, it's a collision, and that's why you cannot have the duplicate. So um,
So for
that holds for even user defined data type, so it needs to know how to generate the hash code. So yeah,
sorry to
maybe.
interrupt, sir. In the case of employee, if I am generating another employee which is the same, suppose I have employee two, and it has the same values for all the attributes as employee 1, then when I'm putting it in the hash set, the hash code of the employee 2 would be different than employee 1, right?
So if you have overridden it, then it's up to you, right? Because
Suppose I'm
here
not.
you are simply in your case you said you are just returning the name. So if the names are same, then hash code would be the same. Okay, so yeah, let's, you can get back to this one. Okay, so now we have looked at one instance of how to do this overriding of equals, right? So you have overridden it. So in terms of the intention, this is correct, but the issue here is the data type of the equals method is now different. So you are no longer overriding the method that was there in the object class. So for in that case, it should have been the object here, object data type, and not point data type. Okay. Second, again, um, this doesn't, this is still not correct. So let's say you have fixed that issue, you have replaced um, the point data type here with the object data type, which is supposed to be the case, because this is how it's defined in the object class. But again, this is, there are still some issues with it, right? Because here the issue would be in this line. So you're saying o dot x and o dot y, but O is an type of object, and object does not know about x and y. So point knows about x and y, but not object, right? So if you say O dot x and O dot y, then it will result in an error. Uh, so the way to fix it is you need to do you need to typecast it. You need to say first that O1 should be of type point, and then you can start using, you can say O dot x and O dot y. So which is the case here, right? So you have O1 here, which is of type object, but you're typecasting it to point, and then you can start using, you can make these comparisons. So this typecasting works because um, you are passing in the value of an instance of point here to this particular equals method. So let's say you're calling it on P2. So you created P1 point P1, and you created another instance point P2, and now you want to check whether P1 dot equals P2. So that's your call, method call. So you would be passing the instance of point to this equals method. So so if you look at it in terms of the code, this is how it would look. So it will say point object over would now be referring to new instance of point. So since that is the case, and by default object is the superclass of point, right? So this typecasting would work. So because anyway O1 was holding or referring to the instance of point.
Excuse me, sir.
Yes.
So in that case, so whenever, so let's say in a very vague example, so I have, let's say, an object of car and an object of bike. So even if I implement my custom equals function, even if I override it, then so it would be only used to compare car objects, right? So
Yeah.
so if I compare a car and a bike object, won't it result in an error when we typecast that object into a car object? Because we would be passing a bike object,
Yes,
so
yes.
it should result in an error. But ideally, it should return false. Like, because a car object can never be equal to a bike object.
Right.
It should return false, but not an error. So why would that happen?
Okay, so we'll be handling that case. I think in either in this slide or next slide. So that's exactly the issue here, right? So if you this is still not correct because of the issue that you point out. So if you pass in say car, again object would take in the car instance also, because object is a superclass for every other class. So but you're sort of forcefully typecasting it to some other instance here, some other type. So that's the issue, and you need to be careful with typecasting here. So um, yeah, so if you pass a non-point type objects also, I mean, yeah, you are
Excuse me,
still,
sir.
yes,
So, sir, would we be using a try and accept block?
yeah, we'll come to that, but not here, I think. So okay, we'll be making a few checks, like as to what should be the type, the incoming type that we allow. So we'll be making a few checks, but let's see. So it's, there are a few things that needs to be fixed, and then at the end of it, if your questions are still not answered, we can revisit them, right? Okay, so here in this case, we can take this example. So you have O1, which is of type point, which is a, I think that is okay. And now, but the O2 is of type string. So and the call is O1 dot equals of O2. So you are passing a string type here. And within this code in line 6, you are typecasting the string to point, which should not be the case, which should not have happened. But so that's why there's a flaw in this code and it needs to be fixed, right? So in this case, you will get this class cast exception. That means you're trying to typecast something which should not have happened. So here we'll be making use of this keyword called instance of. So it's say, so what it does is, if you say variable instance of type, it will return true or false. So for example, you can say P1 instance of point, which is true. So, but you say, if you say in this case, say hello, string s equals hello, and s instance of point, in that case it's false. Right? So it will test whether this variable belongs to this particular type or any of its subclasses. So that's also okay. So here is a table that lists out a few possibilities. So let's say you created two instances. One is of type string and other one is of type point. So now if you say s is s in instance of point, that's not the case. It's false. S is of type in string, so it's true. P is of type point, so that's why this is true. P is not of type string, so this is false. And P is of type object, because object is a superclass of everything, so this is true. And S is also the type of object, so this is true. In the last two cases, it refers to null. So null here again, it's not, it doesn't belong to any particular type. Null is just a it's a reference that says that okay, there's no it doesn't point to any particular memory location. So if you say point P equals to new point, then there is a memory location that gets created and P points to that particular memory location. But if you assign null to it, then so it's like saying there is a memory location, but which is void, like there's no legal memory location that it points to. So in that sense, null is not of any type, right? So that's why it returns false. So okay, so now let's see. So we can make use of this instance of, and then try to fix the issue that we found in the earlier slide, which is that you can now pass any type to this, and it will try to typecast it to point. So now you are checking whether O1 is instance of point. So that means only if it is of type point, you are trying to typecast it. If not, you don't do anything. So you return false. So you first do the typecast, then you do the comparison, and then return the Boolean value. Right. So is this clear so far? Okay. So so this code is still not correct. Right? There are still some issues with this. So the issue is with the inheritance or extension. So let's say you have point 3D. So this is a 2D point. You have x and y, but now you are creating a new class called point 3D that extends this point. and you have a third dimension which is referred to by Z. So you create the corresponding constructor, and now let's say you have this kind of code. So you create point P1, um, so which has these three x, y, and z values, which is 1, 2, 0. You have point P2 which has 1, 2, 3, and you have point P3, and these of type point, and the first x and y values are the same for all the three. Right? And as we have seen in the previous slide, instance of works even if it is of a subtype. So if you say P1 dot equals of P2, it will P1 again, since it's extended point, it inherits this equals method, right? So now you can use equals on point 3D type instance also. So you have P1 dot equals of P2. So P1 is of type point 3D, P2 is of type point 3D, and in both the cases, the x and y coordinates are the same, which is 1 and 2. So this will return true, although the z values are different, right? So that's the issue here. And P2 dot equals P3 also returns true because you have the same x and y values, and it's the same case with P3 and P1, right? So this is an issue here. Um, so let's see how to fix that one. Um, so again, you are doing this typecasting, which is okay, but the way to fix it is you have to override this equals even in the subclass. So in the subclass, you override equals. You are now checking again whether O1 is of, for instance, point 3D. And for the x and y coordinates, it's okay. Like you can use the same comparison, right? So that's why you say super dot equals. But for the z parameter, you need to be careful and you need to do that comparison in this particular equals. So you do the comparison here. So now the issue that was there in the previous slide, it gets resolved. Right? But again, there's yet another issue here, which is highlighted, right? But are there any questions so far? Okay. Right. So the issue here is that it's not symmetric in the sense if A equals B, then B should also be equal to A, right? So that's the symmetricity. But in this case, we cannot have the symmetric behavior. So an example is given here. Let's say you have point P1, which has the values x 1, 2, and you are creating another point which is of type point 3D, and here you have 1, 2, and 3. So if you check for P1 equals P2, so P1 is of type point, so this particular method gets called, and since x and y values are the same, it is okay, it returns true. But P2 dot equals of P1 is false because this particular method will now get called, and since it has comparison with the z value also, this will return false. But ideally, both should return false, right? That's the symmetricity. Yes, was there a question?
This P2 dot equals P1 returns false because of the else statement, right? Because there is no Z of P1.
Right. Yeah, right. You are right.
Z because.
Yeah. Sorry, yes. Yeah, there is there is no so O1 here would be P1. P1 would be passed in as to the argument. So yeah, P1 O1 would now refer to P1, and P1 is not an instance of point 3D. So yeah, it will go to that. You are right. Okay, so we'll just go over these basic rules, right? So in terms of equality, if equality is reflexive, so A should be equal to itself, and it is symmetric. So if A equals B, then B should also be equal to A, and it's also transitive. So if A equals B and B equals C, then A equals C. Right? and the other case that needs to be handled is a null case. So A is not equal to null, and it's false for every object of A. Right, these are some of the basic rules, and I mean these are pretty intuitive, right? Anyway, so the issue here that we are trying to fix is this, that of symmetricity. So P1 dot equals P2 should also have been false, but let's see how to fix that. Okay. So now to yeah, let's discuss this mechanism, right? So the issue there was if you use instance of, then it can be either the exact object or I mean the exact type, or one of its subtypes will also work, right? But instead of that, if you use something specific like get class, then unless it's the exact type of the past object, let's say you passed P1 in your um, yeah, if you say P1 dot P2, sorry, P1 dot equals of P2, unless the type of P1 and P2 are exactly the same, this particular part of the equality does not return true. So P1's get class is, let's say, point. So you're comparing that with P2's get class. So unless these two are exactly same, this wouldn't work, and that's why it's called a stricter. It is more strict compared to instance of. Right. So so you first check that, then you do the rest of the things which we already have done. So which is, first step is to typecast it and then check um, the x and y values. So in this case, if you go back here a bit, so we are checking for the get class of P1 and we are comparing it with the get class of P2. So unless both are same, uh, it will not continue, or it will be so this if statement does not get satisfied, so it will go to else and return false. So we do that for point 3D as well. So you check for not null, and then you check for the get class for each of them, and if it is true, only then you proceed. Um, and there's also a minor modification here, right? So you are typecasting it, and I think we covered it, but anyway. So since O1 consists of three instance variables x, y, and z, and you are anyway comparing x and y in the superclass equals, right? So that's why you call the super dot equals, just to save the code and the time, and you compare it with the z value. If all of them are equal, it returns true. If not, it returns false. So are there any questions so far? So this is how you should implement the equals method. Any questions before I go to the next subtopic? Okay, so let's move to the next one. So, so this one is about the comparisons. So you already did one sort of comparison, which is the equality, right? But what if you want to do, if you want to compare, say use less than, for example, less than operator and greater than operator. So then it's harder, right? And this is, let's say you want to use this for on user defined data types. So let's see how we can accomplish that here. So let's say these colors are objects. So if again here we are comparing the color itself and then the size also. So both these colors are same and then the size is also same. So the equals will return true. But here the colors are different, so it's false. But what happens? How would you check the less than and greater than? So what if you want to compare object 1, whether it's less than object 2 or vice versa. Right? This is important when you want to, for example, sort the list of objects of one particular type. So for example, this is less than this one, this is again less than the third one, and third is less than the fourth. Right? And you are sorting it based on the size. So if we use equals, then we cannot do this sorting, because equal simply gives out the Boolean value stating whether A is equal to B or not. And we cannot use the less than greater than operator directly. Right? So the solution is to do this comparison, which we'll be looking at in next couple of slides. So this compare to method that will take in, so let's say this is P1 dot compare to of P2. So if P1, this one is less than P2 in some sense, right? And what that sense is, we need to define. So for example, in the case of employee, you are saying that the IDs, let's say, are different, and then P1 ID is less than P2 ID, which are integers. Then it will return 0. So it will internally, it will simply do a subtraction. So it will simply subtract left hand side minus right hand side. So since the left hand side is smaller, it will return a 0. If it will return number less than 0. If it is if the left hand side one is larger, then it will return a number which is greater than 0. And if both are same, since you are doing subtraction operator internally, it will return 0. Right? Is that clear so far? Okay, so let's go. So in order to implement this compare to, I mean, which returns the values, whether it's,
इतनी चॉकलेट किसने खाई है?
you should mute.
मैंने तो खाई नहीं मम्मी, एक तो खाई.
So in order to implement the less than and greater than, right, you would have to implement this interface called comparable. And comparable has only one method which is declared. I mean, at least that is of concern here. So later on we'll see if there are other variation also, right? So here we are only worried about this compare to, and that takes in one parameter which is of which can be of any type T. So for example, comparable can take an employee or a person or a human or an organization. So any type can be given, so it can hold any type. So that's why instead of having specific types, so we are referring to it as T, which is a generic type. So now it can, comparable can take in any type, because you said you didn't explicitly specify it. So you said any type would do work for me, and that's why you just left it at T. Right? So, okay. Now let's say you want to compare these rectangles, two rectangles. So you have the class rectangle, and since you want to do the comparison, it should implement the interface called comparable. And you are checking objects of type rectangle, right? So that's why it should be of rectangle type. Comparable takes in a type which is of rectangle here, right? So now there are instance variables which are side A, side B, and area, and you have the constructor. So like I said earlier, you are interested in the compare to, and it returns an integer. So it's either less than 0, equal to 0, or more than 0. And you plan to do the comparison based on the area. So if both the areas are same, then it will return 0. And if let's say the area on the left hand side is less, yeah, it will return -1, and yeah, and then If it is greater, then if you return positive number, which is greater than 0, which is 1. So is this clear so far? So if you don't want to implement it this way, that is also okay, as long as you return an integer, right? So you should have your own implementation for the compare to method using the override. Okay. So there's obviously a difference between compare to and equals. In equals, you are checking for the exact equality, and in the compare to, you can check for less than values and greater than values. Right. So some examples are given here. Let's say these are couple of triangles, right? So you have triangle R1, and then there are two sides to it, or two parameters, 2 and 32. In the case of second rectangle, the x and y coordinates are different, but the area is the same. So that's why you need to be careful whether you are referring to this one or yeah. Okay. So yeah, a couple of questions. So if you say R1 dot compare 2 of R2 here, so what would happen? Okay, one of you can unmute and let me.
Is true.
Your voice is not clear. It broke up.
I said it will result true
True. Yeah. Right.
since
Right. Right. Right.
since the
Because it will
since
return a
both
0.
areas
Right. But is this? What about this one? R1 dot equals of R2.
false since their sides are not equal.
Right. So yeah, their sides are not equal, and in the comparison, you are trying to compare the area and not the sides. But in equals, you are trying to compare the sides. So that's why equals would return false and comparison would return true. Yeah. Oh, sorry. Um, so now, what if you want to do comparison on using more than one different style? So, for example, you may want to compare just on the site A and not on site B, or vice versa. Or if you just want to compare based on the area. So how do you accomplish that? So there is one more feature, um, or sorry, one more method declared in the comparator. So this is called the compare method. The compare method takes two arguments. So this is not compare two, right? So compare two is the method that we discussed earlier. So this is compare, just the compare. So it takes two parameters, t of first and t of second. T is the generic type, which it gets here. Um, so the advantage with this is you can now have multiple types, um, and you can have these multiple different orderings and so on. So I mean, so this would become clear after we see an example, I guess. So let me skip this one, go to the example first, and then I can come back later on. Okay. So let's say you have this rectangle area comparator. So now you want to compare based on the area. So you can go ahead and do so. Um, so it takes two parameters R1, R2, and then you are comparing it on area. You can have one more comparator that compares the sides. So here you are comparing the side A and side B of R1 and R2, right? So if you plan on doing these different comparisons, yeah, then compare is better than comparator. So in this example, right, you created two rectangles and you have the area comparator and the size comparator. So using the area comparator, you can compare their areas, and using the size comparator, you can compare their size. Right?
Excuse me, sir.
Yes.
In this case, we are creating a different class for comparison, right? So if we have to
Right.
incorporate it in the same class, then what about that? Like, if we don't need to, like, is there a way to not create a class? Cannot we define it inside the class itself?
Oh, within rectangle.
Yeah, like in the sense, the compare function for rectangle would be inside the class rectangle itself.
Yeah, we can do that. We can do it. Because there's no, I mean, yeah, you can say rectangle implements comparator. Uh, but the only issue is, okay, so compare takes two instances of rectangle. Right? So you cannot, in that sense, it will become a bit redundant. Yeah. So if you say R1 dot compare of R1 comma R2, which looks a bit odd.
Okay, thank you,
Huh.
sir.
So yeah, so here you can have the side comparator and the size, the other comparator, area comparator.
Excuse me, sir.
Yes.
So, if we like implement the comparator in class itself,
Hmm.
then I think we won't be able to pass it to a built-in sorting algorithm.
Hmm, 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 hmm.
I think that's the only disadvantage.
Right, right. So yeah, we'll come to that. Okay, I think that's an example. That's a good point, and yeah, that's like right to the next slide, right? So, um, okay, so why not we discuss it since you anyway mentioned it. Um, so the main advantage of, or the reason to use this comparator is if you are trying to sort some, say, list that holds not the basic data types, but the user defined data types, something like the rectangle in this case, or the employee. So if you want to sort the employees based on their join dates, then you would have to use the comparator. Right? Like, or else you need to implement your own sorting algorithm, or there is this collections, there is a sort method in the collections class, in the collections, yeah, in the collections class, and then you can use this sort. Right? So if the first argument is the list, so in our case, let's say it's a list of rectangles, you would need this comparator. So you can either pass this, which in this case, like you said, it's not possible. So if you have the rectangle, if you implement the comparator within the rectangle class itself, so you'd have to say new rectangle, which uh, so it's better to separate that, right? So your list contains rectangles, and you are creating a comparator for sorting or comparing these different rectangle values. Right? So I don't know, did that help?
Yeah, yeah, sir. Thank you.
Okay. Yes, was there another question?
Yeah, sir. How do we define a comparator inside the class?
Oh, using, that's the earlier example that I gave, right? The compare to. Okay.
Yeah, that I got compared to, but can
Huh.
we define a compare function inside the class?
Yeah, in theory you can, right? Because it's just an interface. I mean, there's no uh, like. So the only issue would be like, so within the comparator, so you'll be, so you'll have the public class rectangle implements comparator, and that is also of type rectangle. But yeah, so it's very similar to this. So in that sense, yeah, you can do that. But so the difference, look at this difference, right? For example, here you would call this with an object. So you will say that say R1 dot compare to of R2. So here you are implicitly passing R1, for example, as one of the arguments, so to say. But here that is not the case. You need to pass in two arguments which you want to compare, R1 and R2.
So if I
So you
define,
cannot. So if you want to use this, let's say on R1, let's say you want to compare R1 and R2. So it should be it will look odd. So it will say R1 dot compare of R1 comma R2, which is odd, right? So it's easier and cleaner if you just separate this out and then push it to outside of the rectangle class, something like this. Right? Did that answer your question? Or
yeah, so it looks better, but if I have a comparator, if I implement the comparator interface inside my class, then I can't use it in the collections method or sort method of collections, right? Is there a way to do that?
if you want to use the compare method,
Yeah.
okay. So why is that not the case? So you have here you have a list, and the list holds objects of type rectangle. And instead of new rectangle area comparator, you simply say new rectangle. I haven't tried it, but yeah, it doesn't. At least by syntax, it looks okay, right? So what is? Uh, so why do you think that won't work?
Because if you're saying new rectangle area comparator, this creates an object of the rectangle area comparator which has the compare method defined inside it.
Right. Hmm.
But if I say new rectangle,
Hmm.
then can I be, because I don't know, I'm confused.
Yeah. So in terms of syntax, I don't see any issue there. It's just that um, you are mixing up everything. Like you are mixing up the comparisons with the actual class itself. So in that sense, it's not a good design, so to say. But yeah, I don't see the issue in terms of the syntax. Why it wouldn't work? So you can give it a try. I'll also check it.
Sir, actually, it
Hmm.
might be the case that when implementing a comparator, we need to provide the class which we are implementing the comparator. And if we are implementing comparator inside that very class, then I think it might not be defined. Can you show once the definition of in comparator?
So that's okay. So here it
See,
is, right. So it's simply implementing the comparator
comparator of type
interface.
rectangle.
Yeah.
So if the class is a rectangle itself and it is implementing comparator of rectangle. So doesn't it seem
We
like
did that here, right? See here. I mean, rectangle, and then we are implementing a comparable interface which is of type rectangle. So yeah. So I don't. So that's why I said in terms of syntax, I don't see any issue. Um, but yeah, we can try it and see. But yeah, I don't. I mean, in terms of design, it may not be the best way to compare. So um, so it is very similar to this, except that you are implementing a different interface. So here it's comparable interface. Here it's the comparator interface. Right. So it should be okay. Right. Shall we go on? So you can check it. I'll also go back and later on, and I'll check it on my Eclipse. But I don't see any issue in terms of the syntax. Yeah, but in terms of the design, it looks a bit awkward. But syntactically, I guess it's okay. So is that okay? Shall I go on? Or do you have any further questions?
Yes, no problem.
Okay. Okay, so we move now to a different topic. So we have looked at equals, and we have looked at a way to compare the different instances if they are not of basic data type. So let us look at a different. These also, okay. The connection is that all of them, even the procedure that we are discussing. So it's a method of the object class, which is clone. So, but here we'll be looking at how do we copy different objects. Right? So let's say if you have P1, and if you want to make an exact copy of P1, right? And how do you do that? So generally in other languages or even in Java, you have this copy constructor. Right? So that's one way of doing it. So you can create one more constructor, which is of type. So like I said, the point of all this is to create an exact duplicate copy of one more object. So you already have P1, and now you want to just duplicate P1. So you have this constructor that takes in the point, or which is the exact type that for which the constructor is for, and then you simply make this assignment. So that is one way of doing it. So there is one more way, which is to use this method called clone. So clone is a method that is defined in the object class. So every class by default will have access to this, because every class by default inherits from object. So yeah, it does have access to the clone. But the definition for clone in the object is you would have to again override that clone, because okay, there are a few constraints, right? Like you need to implement the interface and so on. But okay, we'll come to that. But in general, you would have to, unless you override the clone, it is not possible to say that your particular type that you define, which is let's say point or person or employee, is ready to be cloned. So in order to facilitate the cloning process, you would need, one of the steps is to override the clone default. There are a couple of requirements, right, that you want the clone to satisfy. So you don't want the clone to have the same reference. So if you say x dot clone, so you're cloning it, but that means you're creating a copy of it, but the instance or the reference of x should not be the same as the reference of that clone. They should be two different memory locations, two different references. Right? And then the second requirement is that when you clone them, the state of the two instances, one is the actual original object and the cloned object, the state of both these objects should be the same. So in that sense, the clone should be equals to the original object, which is x. So the state should match. Right? And the last requirement is that both should obviously be of the same type. So if x is of type point, then x dot clone should also be of type point. Right? So this is the general intention that you have, or at least this is how you want the clone to work. Right? So let's see how we can accomplish that. So the first requirement, like I said, is you would have to override it. So let's say you have this point class, and you want to support cloning. Right? You want a point to support cloning. So in that case, you would have to override clone method. So if you don't do that, then you will get an error, right? Something like this. So the second requirement is that your class should implement an interface called clonable. So this is just to say mark the class, saying that okay, this is now compatible or this is now ready to be cloned. right? So these are called as marker or tagging interfaces. Right? There is no other purpose any but just to mark them, because clonable interface is empty. There is no other method that is declared in the clonable interface. So in that sense, you don't have to provide the body or provide a definition for any of the methods because it's empty interface. So by marking any particular class, we are just specifying that this is ready to be cloned, or we are okay for this particular class to be cloned. So that's the only reason to provide this marker interface. So there are also other couple of marker interfaces. Um, Something like there's something called serializable. Right? So let's say if you want to, I don't know if we'll call it, but let's say if you want to store the instances in a file. So you want to write a particular instance or the values of that instance as it is to a file. Right? So that's the serialization process. So if you want the instances to be serializable, then you need to mark those classes as serializable again. So yeah, so this is the utility of the marker interfaces. The Java language, the compiler, it will complain. So it's a hint to you that you need to again use these interfaces. Again, this is not the right usage of the interface, but this is something that comes from the legacy Java, right? Like the older versions of Java. So if it was a newer version, maybe you could use something like an annotation, like the @ symbol. But this is how the legacy versions used to work. So it got carried over. So yes, so there was a question.
Yeah. So could you again explain this tagging or marker interface?
Tagging or okay. So it will simply say that you are giving the permission for this particular class, which is point in this case, to be cloned. So it will simply mark it. There is no other usage or utility for it. Right? So there's one more example, let's say the serializable example that I said. Right? So if you want to store the values of the instances in a file, if you want to write the instances to a file, then you need to say that the class should be serializable. So unless you specify that, the compiler will not allow you to proceed. So it's just a mechanism to state that this class is ready to be cloned. Not ready, but at least it's okay to try cloning this class, because the other things should also work. For example, you need to override clone method, right? But you are simply conveying to the compiler that this class can be cloned. That's it. So it's like tagging it or marking it. So did that help?
Yes, sir. Yes, sir. Thank you, sir.
Okay. Okay, so let's implement clone for the point class. So the first step, like I said, is to implement this clonable interface, and clonable interface is empty. So in that sense, you don't have to bother with defining the methods and so on. Right? You just have to implement it. But the other requirement is to override the clone method, and this comes from the object class, because every class by default inherits from the object class. It will also inherit all the public and protected methods, and clone is one of them, so it will inherit this, and now you want to override it. So the way we are overriding it is okay, we are creating a new instance, and we are passing the current state to this new instance, so which is this .x and this .y, and you are simply returning the copy. So this is the first cut, but there are some issues with it, right? Let's say you have a point 3D, so which inherits from point. So it also so whenever you extend point, you are automatically saying that this is also ready to be cloned, because it by default implements clonable, right? Because point has implemented clonable, and point 3D is inheriting from point. So it is like saying that you are also marking point 3D to be clonable. But the additional instance variable that you have here is a Z. So you have Z also apart from X and Y. And now let's say since you inherited from point, you are also inheriting the clone method that you defined here. So now point 3D also has a clone method defined, which it inherits from point. And if you invoke the clone on point 3D, it will return a point and not point 3D, right? Which is not what you wanted. So if you call the clone of point 3D on point 3D's instance, let's say it's P3. So if you say P3.clone, you expect the type to be point 3D and not point, right? But that will not happen here in this case. So the only way to ensure that would be to use this call called super.clone. So let's go back and revisit that clone implementation, right? So you have point implements clonable, and it in your overriding clone, but instead of creating a new instance yourself, you simply say super.clone. But super is now referring to the instance of object, right? Because that's the super class for point. So super.clone would return a type of object which you don't want. So you need to just typecast it and return the point. So that's it. So this will fix the issue. And the other requirement here is that within the clone, whenever you call the clone, it should always be within this try and catch block, which we'll look at it later on. So when we look at the topic called exception handling, we'll look into this in more detail. But I'll just briefly summarize this, right? What is a try and catch? So try and catch. So whenever you want to monitor a particular piece of code, because it might throw some errors at runtime, right? So for example, if you are dividing two numbers A and B, and both these numbers are let's say come as arguments, right? So for example, if you have something like public int divide, say int A comma int B, and let's say you are simply returning A by B, right? Just a simple example. So you don't know what the values of A and B are. It's passed in. You have no control over it because these are not explicitly defined, and any client which calls this method can pass any value of A and B. So now, if it happens that you pass in, and this is the call, right, 5,0, you end up with a division by 0. And this happens at runtime because these values can be passed only at runtime, right? Because you haven't declared what the values of A and B beforehand. Okay, so in order to, so there's a requirement to monitor this piece of code. Because unless you monitor it, you will get an error which is divide by 0. And the whole application will crash, right? It will suddenly stop and crash. And that is not something that you would want. So you want to handle these kinds of things graciously, so to say. So even though it happens, you would have to provide an exit mechanism or a mechanism to recover from this error. So try and catch does that. So it will allow you to recover from these runtime errors graciously, so to say. So you use this try block. So these are called blocks because you have these parentheses. So there is a try block and there is a catch block. So you use the try block to monitor a piece of code that may throw some kind of runtime error, and you use this catch to, as the name says, to catch that particular error and then handle it. So in this case, it could happen that this clone not supported exception could be thrown. I mean, it could come out of this piece of code, and if it does, you are handling it here, and if it does not, it's okay. So this will never get executed. Right?
Excuse me, sir.
Yes.
So when you call point copy is equal to point super dot clone, so what exactly does this super dot clone return? Like in the sense, when we implemented our own clone function, then we implemented it as that we are creating a new object with the same attributes, with the same x and y attributes. But what will super dot clone return here?
Huh. Uh, okay, so let me just wrap this try and catch part, and I'll come to that. So yeah, so that's the whole point of this try and catch, right? So you use try block to monitor a piece of code where some runtime error can come in, and you use this catch block to handle, if at all some runtime error comes in, you can try and handling that within the catch block. But if there is no runtime error, this catch does not even get executed. You simply go over the try and then just come out of that block and continue with the rest of the lines. So that's about try and catch in brief. So like I said earlier, we will again revisit this at some point, because we have this exception handling in a different lecture. Right? So we'll go over it later. Okay. Okay, one more point and then I'll come back to this question. So if you are implementing clonable, so if you say that point implements clonable, so you are marking the point class with this clonable interface, then this exception will never be thrown. So you will never get a clone not support exception. But that's the, what do you call, the syntax, right? Because super top clone requires that it may throw an exception. So that's why it is required that you try to handle it. So even though you have implemented clonable, it's still required that you put this inside the try and catch block. But this will never happen if you implement the interface. Okay. So yeah, that's about the clone. So yeah, now about super dot clone. So if you invoke super dot clone, right? Super here refers to the instance of the object class. So you are calling the clone on that, but since it is of type object, you want to typecast it, and that's why you need to do the typecast also. I don't know, did that help? Did that answer your question, or was that different? Was your question?
So, like my question was, so super dot clone will return me a new object of type copy with the same attributes.
Yes, yeah, it does.
But so let's say let's say the class is employee and it has an array list of, let's say, uh, in marks, something. Okay, class student, and it has an array list of marks. Now if I write student copy is equal to student super dot clone, so will that array list so that array list's reference will be copied at that, or that array list will be deep copied?
No, we come to that. So that's in the next couple of slides. But so what it does is, let's say, so it will just simply copy it. So it's a so if you are aware of it, then it's a shallow copy. It's not a deep copy. But I'll show you this example, right, which I have written. So you have your test clone. It implements this clonable. So you have your two instance variables, which is ID and name, right? Okay, so apart from this constructor, so you have your clone method.
Excuse me, sir.
Yes.
We are implementing, we are using super.clone, but super is from the object class, and object class is the super class. So, shouldn't object class not be able to access the members of its base of its derived classes?
Right. Yeah. So it will not be able to access. You are right.
So how is it even making an object which is having same data as the original object?
Okay. So, Okay, so there is this cloning. Okay, you're right. Okay, that's a good question. Yeah. Okay. Yeah. Okay. I can't. So okay. Let me. So I'll have to check that. You're right. If you just go by the line that was put out here, it should not have happened, right? Like you have your super dot clone, so you're calling the clone on the object, and you are right that object does not know this ID and name. So let me look it up. Let me also I don't know, try and understand it a bit more, and then I'll either post it on the classroom or I'll discuss it in the next class. Right? But it does work. Yeah, but I'll check how it works or why it works the way it works. So just to check whether it works or not, I did try it. Yeah, but yeah, I can also look at how or the reason behind why it works this way. Right? I'll look up the reason and then I can get back to you in the next class, or I'll post it on classroom, whichever one of them I will do that. Okay, so does that is that okay? Madhu, right?
So,
Yes, sir. Yes, sir.
Okay. So let me just
one last thing, sir. Yeah, sorry to interrupt.
just say that it works. So because so you have your T1 and I created a copy of, sorry, I created an instance of it and then I simply said T1.clone. Right?
Excuse
And
me, sir.
so it's printing T1 in it. Okay. Yeah,
Excuse
I
me,
just
sir.
wanted to just say that this statement works, but yeah, go on. What was your question?
Okay. I thought I was not audible. So sorry to interrupt. So actually, I was just confirming. So you said shallow copy. So shallow copy is what happens in super.clone, right?
Right.
Okay. Thank you, sir.
But we will be coming to that in the next slide. I think next couple of slides we will be looking at it. Okay. So yeah, the super.clone. Let me that. So yeah, so it's so here the clone method. It again you have overridden it and you have called the super.clone, but you are typecasting it to point, right? So if you do it for point 3D and if you don't override it, then it will reuse the same implementation, which is not what you want, because if you are calling on point 3D, then it should return the clone of type point 3D. So in your subclass also you need to override it or re-implement it, and you call the super.clone. So in this case, the super.clone refers to the point clone, right? The clone in the point class, which already copies X and Y, right? And now you are simply um, doing it for the new variable, which is only in point 3D, which is Z. So you're saying p dot z equals this dot z. So you're cloning or you're replicating the instance or the state of the entire point 3D here, right? So, so the takeaway here is all the subclasses should basically re-implement clone method.